Hello guys, this is Miss Dixon again. Welcome to lesson 17.6. 17.6, we are going to start looking at dividing decimals by decimals. That's right, our dividend and our divisor is going to have a decimal in it. And you have to go about solving it slightly different. Now, I'm going to talk about how the book does it. But then we're kind of going to go into how you really can go about solving these, and it's not as confusing, but I do want to give you the background of why we're going to do what we do, which is what the book is setting you up for. But we're just going to, once we get into that, we're really going to get into just going ahead and getting those steps done, because as we all know, sometimes why we do stuff in math is not the important part, it's just how do you solve it. Sometimes you need to know why, but most times you just want to know how to get to the answer. Am I right? Of course. All right, so let's get started. Let's look at our first problem. Marisol sets up a lemonade stand. At the end of the day, she has made $8.75. How many cups of lemonade did Marisol sell? Oh, and I'm sorry, guys, I forgot to tell you what page we're on. We're starting on page 443. Make sure you have those books out. Open to page 443. If you need some time to get your book, just pause the video and get that book out. Open to page 443. Page 443. All right, so let's look at problem A now that you have your book out. What is the division problem you are trying to solve? So if you look at the problem, we see that Marisol made a total of $8.75 from her lemonade stand. We want to know how many cups of lemonade she sells. If you look at her picture, how much is she charging for each cup of lemonade? Take a look at that picture in your book. It's a little fuzzy on my screen, so that's why I'm saying look in those books. How much is each cup of lemonade? 25 cents. So she made a total of $8.75, selling each cup for 25 cents. Don't forget your dividend is going to be what she ends up with, her total, what she has. She has $8.75. The divisor is going to be how she splits up that total, that $8.75. She splits it up in groups of 25 cents. And that will tell us how many cups she sold. So what would be your division problem? What would be your dividend? What is our total? That's right. Our total is $8.75. So that is our dividend. And how did she split it up? What is our divisor? That's right. It is 25 cents or 2500. So our division expression is going to be 8.75 divided by 2500, or 0.25. Right? Question B wants us to put it in a fraction. So we want to rewrite this problem as if it were a fraction. Now, we learned when we were studying fractions that your numerator is the same as your dividend. That is the number inside of the house, or your total, the amount that you have. Your divisor is going to be your denominator, or how you separate or split up your dividend. So how would we write this problem as if it were a fraction? We want to put our dividend in the numerator position, the top number, and our divisor as the denominator, the bottom number. So that would end up being 8.75 over 2500. Okay, so again, your divisor is going to be your denominator, that bottom number. your dividend is going to be your numerator. Whoops, the top number. Let me erase that little mark right there. Your top number. All right, our next question says, what number could you multiply the numerator and the denominator by to write an equivalent fraction with whole numbers? What is the equivalent fraction? So remember, if you are writing equivalent fractions, that means you must multiply or divide your numerator and your denominator by the same number. You cannot multiply your numerator by one number and your denominator by another number and it be an equivalent fraction. If your numerator is going to change, your denominator is going to change. If your denominator is going to change, your numerator is going to change. So you have to make sure you multiply both by the same digit. Now we're trying to get our fraction of 8 75/100 over 25/100 into whole numbers, or 875 over 25. Let's start with figuring out what we can multiply that denominator by to get it to a whole number. Because whatever we do to the denominator, we must also do to the numerator. So if we can get 25 or 25/100 to a whole number, then we're going to multiply whatever we did by 25/100 also by 8 75/100. So what could you multiply 25/100 by to get it to 25? So right now we have, turn on my marker, we have 25/100 and we're trying to get it to, we're trying to multiply it by something to get it to 25. What do we multiply 25/100 by to get it to 25? Well, we learned that if you multiply a 10 base number that's a whole number by a decimal, we can move our decimal to the right. If we move our decimal to the right 2 places, 1, 2, that's going to be 25, right? So what would you have to multiply 25/100 by to move the decimal 2 places to the right? We know it's a 10 base number, so it ends in zeros. We know it's a whole number because we have to move the decimal to the right. So which number has 2 zeros? Because that's how many places we're moving, and is a whole number. That's right, 100. So we have to multiply 25/100 times 100 to get it to 25. Don't forget your rule. When you're dealing with fractions, what's the rule? Whatever you do to the denominator, you must also do to the numerator. So our numerator is 8 75/100. We want to multiply that one also by 100 because that's what we multiplied our denominator by. That means we're going to move our decimal 1, 2 places to the right to give us an answer of 875. So we are going to multiply both our numerator and our denominator by 100 to give us whole numbers of 875 over 25. This is now our new division problem. Remember, your numerator is going to be your dividend, and your denominator is going to be your divisor. So let's write and solve our new division problem using our new fraction. So that's going to be 875 divided by 25. Okay, so now let's solve 825 divided by 25. Now over here, they're using the standard algorithms form to solve it. We are not going to use that because we have a multi-digit divisor, 25. We're going to use our partial quotients method. I'm going to set it up slightly different, but it's still going to be the same thing. All right, so we got 25 as our divisor and 875 as our dividend. We're still going to start off with our partial quotients. Let's make a list for this one. All right, let's start with 25 times, what do we start with? 10. That is 250. 250 is a number that we can use, but we might be able to go higher. How about 25 times 50? Right? We know we need 1 0, and then 25 times 5. 5 times 5 is 25. Regroup that 2. 2 times 5 is 10 plus 2. That's 12. Oop, 50 was too big. We got to go smaller. How about 30? 25 times 30. Okay, 1 0. 5 times 3 is 15. Regroup that 1. 2 times 3 is 6. Plus 1 is 7. 750. That's a good one. So let's start with 30. And instead of putting it on the side, I'm going to put it on the top. 30 as my partial quotient. 30 times 25 is 750. Subtract. 5 minus 0 is 5. 7 minus 5 is 2. And 8 minus 7 is 1. Can we stop? Of course we can't, because our remainder, 125, is more than our divisor of 25. So we have to keep going. All right, can we take out another 30 groups? When we took out 30 groups, we subtracted 750. Can we subtract 750 from 125? Nope, not and get a positive answer, so that won't work. All right, so we got to go lower. Could we take out 10 groups? If we took out 10 groups, we would be subtracting 250. We can't subtract 250 from 125, so we have to go even smaller. What would you like to add to our list? How about 3? Okay, so 25 times 3. If you look up here, we've already solved 25 times 3. That's 75. 75 would work. It's a little far away. Could we maybe go higher? Some of you might be saying, Miss Dixon, if we've already done 25 times 5 and got 125. So why not do that? 25 times 5 is 125. That would be perfect. Now looking at our partial quotient, we're going to come up here and we're going to put 5 right above the 30. 5 times 25 is 125. Subtract and we get 0. Our remainder is less than our divisor. 0 is less than 25. So we're ready to stop. How do we get our final answer? Add all of your partial quotients. 30 plus 5 equals 35. So your final answer, or to solve it, we get 35. All right, how can you use this quotient to solve the original problem? All right, since if you look at our problem, at question B, where we created an equivalent fraction in question C, since these two fractions are equivalent, that means our answer would be the same no matter which fraction we use because we used equivalent fractions. So since our two fractions are equivalent, that means our two problems are equivalent. So both problems would have the answer of 35. So you would write in question E, our fractions are equivalent, so our answers would be the same. I'm not writing it because I'm writing at home and I'm using my finger. It's a little hard to write. So for F, our how many cups of lemonade did Marisol sell? It would be 35 cups. You see how big I have to write when I'm writing at home? Yeah, so that's why I'm not writing E's answer. All right, so again, E's correct answer would be, since the two fractions 8 and 75 hundredths over 25 hundredths is equivalent to the fraction we solved of 875 over 25, the answer of 35 would be the same for both division equations. All right, let's move on to problem number 2. It's over here, I think. Oh, that's not it either. Where did I put? There's Fred's right next door. Lord, look at me. Sorry, guys. All right, let's look at our problem. Question number 2. James rides his bikes 16 and 32 hundredth miles. He rides about 9 and 6/10 miles each hour. How many hours does it take James to ride this distance? A says, what division expression models the situation? All right, so again, we're talking about a division expression. That means we need a dividend and a divisor. The dividend is going to be the total, how much we have, how much we end up with when we're done. The divisor is going to be how that total is separated, how that total is shared, how that total is split. So what is our total for this problem? That's right. He rode 16 and 32 hundredth miles. How did he split up the 16 and 32 hundredth miles into 9 and 6/10 miles? So we would divide it by 9 and 6/10. My decimal won't show up. There we go. All right, estimate your work. Estimate the answer. Show your work. All right, so let's say that 16 and 32 hundredth is about 16. All right, and 9 and 6/10. Well, let's do it. No, 9 and 6/10 is about 10. What is, hold on, let me redo this because I want to estimate it the way I taught y'all how to estimate. Okay, so we're going to estimate 9 and 6/10. My pen doesn't want to write. 9 and 6/10 is about 10. What number is compatible to 10 that is close to 16 and 3200? How about 20? 20 is compatible to 16 and 3200, but is divisible by 10. So we're going to say 16 and 3200 is about 20. So 20 divided by 10 is 2. So our estimated total is 2. All right. How can you write the division problem as a fraction? Okay. So that's going to be 16 and 3200 over 9 and 6/10. All right, so now we want to get, in question D, we want to get our denominator, or we want to write an equivalent fraction where our number is a whole number, but not both numbers. We want to get the denominator to a whole number. Remember, we always start by getting that denominator to a common denominator or a number first. So 9 and 6/10 times what will get us a whole number. What is the whole number we're trying to get to? 96. That's the whole number. So we know we got to move that decimal how many places to the right? 1. 1 place to the right. What would we multiply 9 and 6/10 by that would move that decimal 1 place to the right, turning it into 96? Well, if we only need to move 1 place, then that would be 10, right? 1 0, 1 place, whole number, so we multiply by 10. What's the rule when we're dealing with fractions and making equivalent fractions? That's right. Whatever you do to the denominator, you must also do to the numerator. So what are we going to multiply that numerator by? That's right. We're going to multiply our numerator also times 10. So that's going to be 16 and 3200 times 10. Okay? That means we're going to move our decimal how many places to the right? Not 2, but 1. Because we have to keep them what? Equivalent, equal, the same. And if you're only going to multiply your denominator times 10, then you're only going to multiply your numerator times 10. So that's going to give us a numerator of 163 and 2/10. So our new fraction is going to be 163 and 2/10 over 96. Notice that your divisor, the number on the outside of the house, is a whole number, but your numerator, your dividend, the number inside of the house, still has a decimal in it. When you are dividing with decimals, the only number that you want to make a whole number is going to be the divisor. You move the decimal, or you're multiplying the number times the divisor to make that number a whole number. And then you're going to multiply or move your decimal the same number of places in your dividend. Notice that we did not move our dividend, the decimal in our dividend, 2 places to turn it into a whole number. We only moved it 1 place to just change it into a different number, or the equivalent to the fraction we started with. You can't multiply one number times 10 and the other number times 100. Whatever you do to the denominator, you must also do to the numerator. So since we moved our divisor 1 place, we must move our dividend 1 place. All right, for E, you are simply going to solve it just like it was a whole number divided by a decimal, or a decimal divided by a whole number. We've done those several times. The only difference is now you have a multi-digit divisor. So let's look at E. Again, right here where they have it set up, it kind of looks like a standard algorithm. So I'm going to redraw this problem and do it as a partial quotient method, because that's a lot easier when you have multi-digit divisors. All right, so again, your divisor is now 96. It's a whole number. We move that decimal 1 place to the right to turn 96 into a whole number. But your dividend still has a decimal in it. That's supposed to be a 2. All right, when you are solving decimals in your division, the first thing you want to do is bring the decimal straight up. Bring your decimal straight up. Then solve it just like it is a whole number. All right, so we know from our estimate that our answer should be close to about 2. That's 2 wholes. So that means we want to start with 2 and 0/10. 2 wholes and 0/10, because we have a decimal. All right, so we want to multiply 20, because we're going to think of this as a whole number, times 96. All right, we know we need 1 0, and then 2 times 6 is 12. Regroup that 1. 2 times 9 is 18, plus 1 is 19. And we can't exactly use 2, right? Because that's too big. So let's change it to, maybe instead of 2 wholes, we use 1 whole. But it's not exactly 1. It's going to be 1 and 0/10, so we're going to think of it as 10. All right, so we need 1 0, and then 96 times 1 is 96. Subtract 2 minus 0 is 2. 3 minus 6 you cannot do, so we need to regroup that to a 7, and that becomes 13. 13 minus 6 is 7. 7 minus 9 you cannot do. Regroup the 1 to a 0. That becomes 17. 17 minus 9 is 8. Can't stop yet because we still have a remainder that is more than our divisor. So we have to take some more out. We can't take out 10. How about 5? So let's try 5. Okay, this is 5 single, not 5 whole. So we're going to put it on the other side of our decimal. So it's technically 5/10, but we're thinking of it as 5. 5 times 6 is 30. Regroup that 5. Write down the 3, the 0. Regroup the 3. 3 times 5. Sorry, 5 times 9 is 45. Plus 3 is 48. We can subtract that. So that would be 2 minus 0 is 2. I don't know what's wrong with me. I can't speak today. 7 minus 8 you cannot do. Regroup that 8 into a 7. The 7 becomes 17. 17 minus 8 is 9. And 7 minus 4 is 3. Got to keep going because we still have some more we can take out. We can't take out another group of 5, so we have to go smaller. Let's try 2. All right, 2 times 6 is 12. 2 times 9 is 18. Plus 1 . All right, guys, I just realized I made a big mistake. That's okay. Remember what I always say? I'm a human. I make mistakes too. This was not supposed to be a 7. This was supposed to be a 5. And I know a lot of y'all were probably screaming, Miss Dixon, that's supposed to be a 5. Sorry, I couldn't hear you. You know, I would change it. I would have already changed it if I did. Okay, so this becomes, instead of a whatever I had there, it's supposed to be 15 minus 9, which is 6. Okay, now I see where, because I was trying to figure out where I messed up. So now this becomes 17. This 6 becomes a 5. Okay, and then that's a 1. Now let's try 2. 2 minus 6 is 12. Regroup the 1. 2 minus 9 is, 2 times 9 is 18. Plus 1 is 19. All right, now we can subtract and we end up with 0 as our answer. Okay, our remainder is now less than our divisor. So we can come up to our partial quotients and we can add them together. Notice that I was bringing that decimal up. So when we add, we can remember the rules for adding our decimals is we line up the place values, line up the decimals. So that's 2 plus 5 plus 0 is 7. Put your decimal because we're bringing it down. And then 1 plus nothing is 1. Is our answer reasonable? Our estimated answer was 2. Our actual answer is 1 7/10, which is close to 2. So yes, our answer is reasonable. And our final answer is that he rode for 1 7/10 hours. I am so sorry about that mistake, guys, but I was able to catch my mistake, which is the important part, which is why we go back to check and make sure everything makes sense. Looking at your problem, E was to write and solve the new division problem. That is this right over here where we do 163 2/10 divided by 96. Our answer ended up being 1 7/10. It says, how do we know the quotient of the new division problem is the same as the quotient from the original division problem? That is because we made equivalent fractions. And if you make equivalent fractions, your answer will be the same. And then, was our answer reasonable? Yes, our answer was reasonable because 2 is very close to our actual answer of 1 7/10. All right, guys, I hope that helps, and I'm so sorry if my mistake messed you up. Don't forget to watch all of the past videos. You will be taking a test on this on Thursday. This coming Thursday. Yes, this Thursday. I think it's April the 3rd. We have one more section to go over tomorrow. There will be a video posted for that and our study guide, which I will give you on Wednesday, and post a video going over the study guide. Please make sure you are reviewing everything because I am not there to help all of you because we are not changing classes. Watch the videos. If you were absent, go back to the videos you missed. If you don't understand anything, go back to those videos or make sure you come and ask me questions. I am here. I'm just not seeing all of you, which is why I'm making the videos. Have fun with math, guys. Practice, practice, practice. Your ACAP is going to be next week, and I know everybody is going to do great. Have a great day, and I hope to see all of you at school. Love you. Mwah, mwah, mwah. Bye.